Hi everyone. We're going to spend one more day on section 11.1 because there's a few more important vocabulary words that have to do with angles that I want to go over with you. So let's start with the word adjacent and what it means to be adjacent angles. The word adjacent means next to or connected to. So in real life, you might hear that like two houses are adjacent, which means they're right next to each other, something like that. Now, in geometry, what it means is two angles are actually connected. They have one ray that is a side in both of them. That's the common side right there. And then they also start at the same point, the same vertex. So a good way to think of it, the mathematical definition has to do with what you see on the picture right now. It's two angles that have a common side and a common vertex. But a really good way to think of any adjacent angles is if I take any one angle like this and I split it up. I draw another ray right down the middle. Anyway, this is not a bisector. It doesn't have to be exactly in half. In fact, I can make it like real close to one of them like this. What you've done is you've created two adjacent angles. Two angles that instead of being separate, they have one shared side and a shared vertex. They start in the same spot. Okay, our next vocab term is linear pair. Now, linear means line, we know that, and a pair means two. So if you take a line, a perfectly straight line, and split it into a pair of angles, we call that a linear pair. It looks like this. So that line across the bottom there, PSR, PS or PR, remember any two for a line. So maybe we'll practice our notation here. Maybe we call this at the bottom line, I'll call it line PR. Even though it doesn't have the arrows on it, the picture I found online, we'll pretend like it had those arrows on the end. And I'll put one up here too on Q. Now what we have is I took that line PR, and then from point S right here, I drew a ray, I'll call it SQ, ray SQ, splitting that into two angles. Those two angles together are called a linear pair. Now they're also adjacent angles, like we just talked about on the last slide, but this is a little bit more specific than that. Now let's learn a theorem. Remember, our theorems are our math rules that have been proven to always be true. Our theorem says linear pairs always add up to 180 degrees. And that makes sense because remember we said in part 1, a straight angle or a line is 180 degrees. If you take a 180 degree angle, split it into two pieces, of course the two pieces are going to add up to 180 because it's a line. So in this picture, angle and when I put the letter M in front of an angle, this letter M right here, the lowercase m here, it means the measure of. So that's when we drew a line segment with no line segment over it, and we said that means how long it is. This is how you do that for angles. If you want to talk about the actual number of degrees in an angle, put an M in front of it for measure of. So we have the measure of angle PSQ, that's one on the left there, plus the measure of angle QSR, that's the one on the right, equals 180. They add up to 180. And that sets us up for a good example. So let's find the measure of angle ABD in this picture. Now, first of all, let me show you a common mistake, which you don't want to do. A lot of people in this question, they go, okay, I see this thing here, I see this thing here. Most questions we do, we just set things equal. So they take the question and they write 7Q minus 46 equals 3Q plus 6, and they start solving. Now you might solve the work, and you might do the work and solve for Q, but the answer you get is wrong. Because right off the bat, you said those two angles are equal. Those angles aren't equal. I can tell the one on the right's a lot smaller than the one on the left. So that's not the work you want to do for this. Don't fall into that trap of just automatically, you see two things in a picture, you say this one's equal to that one, and you solve. That's not the case here. In fact, what we decided here is that what you need to do to solve this one is to say they add up to 180. So instead of making them equal to each other, I'm going to take the first one, 7q minus 46, and I'm going to add it to the second one, plus 3q plus 6. And I'm going to say those two things added together have to equal 180. That's the equation we want to solve. So when we go to solve, we have some common terms here. I have a 7q and a 3q on the same side of the equal sign. When they're on the same side, don't subtract one of them from both sides or anything like that. Just add them together. 7q plus 3q is 10q. And then the same thing with the numbers. Negative 46 plus 6 would be negative 40. So when I combine my like terms, I have 10q minus 40. On the right-hand side, I'm going to leave 180. And see, now it's a regular equation to solve. So the next step, if I want to solve for q, I would probably add 40 to both sides to cancel out the minus 40. That's gone. That leaves just 10q on this side. And 180 plus 40 is 220. And to finish solving for q, we'll get rid of the 10 by dividing both sides by 10. And q ends up equaling 22. But remember, just like our example from yesterday, that's not the answer to the question. Don't solve for q and stop. If you look, what I asked you guys to do is find angle ABD. Well, angle ABD is this one right here. So what you want to do is go back, take your answer, 22, and substitute it in for that q right there. So to finish out this question, what I have is 7q minus 46. And I'm going to substitute. That would be 7 times 22 minus 46. We'll multiply first. 7 times 22 would be 154. And 154 minus 46 would be 108. And I put a degree on it because we're measuring angles. Angles are measured in degrees. So the answer to the question, angle ABD, is 108 degrees. Okay, let me give you one more vocab word and then we'll do a similar example. We saw a picture in part 1 where we had two lines crossing. It kind of makes an X, and it actually creates 4 different angles. Each pair of angles that are across from each other, the ones that are not adjacent basically, are what are called vertical angles. So in this picture right here, this is the picture I was describing. You have two lines crossing. The top and bottom angles, which are numbered 1 and 3, the kind of orange ones, those are vertical angles. So are the left and right ones, the blue ones, numbered 2 and 4. So when two lines cross, it makes 4 angles, and it actually makes 2 pairs of vertical angles. Top and bottom are vertical, left and right are vertical. Now here's our theorem about vertical angles. Vertical angles are congruent. So linear pairs, what we learned in our first theorem, add up to 180. Vertical angles, they don't add up to 180, they are congruent, they are equal. So this is a good picture because it shows both. Like if you block out half this picture, angle 1 and 2, or any two next to each other, I could say angle 3 and 4, angle 2 and 3, any two angles next to each other in this picture are a linear pair. So angle 1 plus angle 2 equals 180 degrees. Now angle 1 and 3 are vertical angles, so they're equal. So we have actually both in this picture. So in this picture, even though I already kind of mentioned that, angle 1 and angle 3 are vertical angles. That means they're congruent. If I told you angle 1 is 100 degrees, so is angle 3. Same with 2 and 4. Angle 2 and 4 are congruent. Maybe I told you angle 2 was 37 degrees. Then so is angle 4. They're congruent. Their measures are equal. So let's wrap up the notes today with one last example. I gave you that X picture, that two lines crossing picture, and I marked 2 of the angles. One of them is x plus 16, one of them is 4x plus 5. So what you have to do is really think about your rules, your theorems, and decide what we know about the angles in this picture. If the angles that are marked are a linear pair, we do like our first example, you add them together and make it equal to 180. But these are vertical angles. These angles are on opposite sides of the x from each other, so they're equal. So this is the one where how I started the last example and I told you that was wrong. That's actually right for this one. So I'm going to take the first one, which is x plus 16, and I'm going to say since it's a vertical angle, it has to be equal to the second one, 4x minus 5. And we'll solve for x. So I have no common terms this time. I do have x on both sides. I want to get rid of one. Let's get rid of the smaller one. So this x over here on the left, remember an x by itself is actually a 1x, even though you don't see it. So let's get rid of that. Let's do a minus 1x on both sides. So that's gone, leaves just a positive 16 since it was plus. And over here, 4x minus 1x is 3x, and it does leave us that minus 5. Okay, next step, I want to get rid of the minus 5. Let's use a plus 5. Same thing on both sides. 16 plus 5 is 21, and that leaves just 3x over here. Last step to cancel out the 3 is divide both sides by 3. That cancels with that. 21 divided by 3 is 7. So we get 7 equals x, or x equals 7. Doesn't matter if it's written backwards. Now I go back and check the question like I always do. The question said solve for x. That means this time I'm done. I don't have to plug it in. I could have asked you how big the angles are, and then you plug it back in like we did in the other problems. But for this one, I just said solve for x. That's the answer.